Okay, so what we're doing is we're starting on 2008. So this is 2008 question 1A on linear, okay? So 2008. A ball is thrown vertically upwards with initial velocity 39.2 meters per second. Find the time taken for it to reach its maximum height. So what you got to remember is the ball's getting thrown up, it's going to travel all the way up, and it's going to come all the way back down. Okay, for maximum height, the velocity at the top is going to be 0. Okay, so v equals 0. Okay, so that's what you have to remember. So first thing to do is UVAS your system, check out your numbers, and let's see what equation we should use. Okay, so when we put UVAS, we're going to go through all our information. Okay, our initial velocity is 39.2. Our final velocity is 0. It's a deceleration because gravity is acting against the ball going upwards, so it's going to be minus 9.8 as a deceleration. We don't know S and we don't know T. Okay, we are however looking for time taken, so T is the target for the first question. Okay, so you can see that we're going to use U, V, A, and T, so that's the formula V equals U plus AT. When we use V equals U plus AT, all we got to do is put into our numbers. 0 equals 39.2 minus 9.8t, and then we can say that spin it around, 9.8t equals 39.2, and t is going to equal 4 seconds. Okay, so t equals 4. It's the first one there. Okay, next question, the distance traveled in 5 seconds. Okay, so once again we got to do a new UVAST. Okay, so this is the new question. Okay, now what we do know about this question is that it's the distance traveled in 5 seconds. So what we know is it takes 4 seconds to get to the top, and it takes a further second traveling down. Okay, so it's going to travel more than the maximum height. Okay, so just bear that in mind. Okay, so there's going to be just 2 different segments to this journey. Okay, so we're going to find out how long it takes to go. Like, remember, S is not actually distance, it's actually displacement. Okay, so you have to find the distance for the maximum height, and then the distance it travels down from this point to this point after 1 second. Okay, so there's 2 separate parts to this equation. Okay, so what we're going to do is we're going to use our original information. This is from start to max height. Okay, so from start to max height, and what we're going to do here is we're going to just find out what S is. Okay, so given that we know all the information from the last set, what we can use is S equals UT plus a half AT squared. You could also use phi squared equals U squared plus 2AS. Both of them could be usable. Okay, so we're going to get 39.2 times 4 plus a half multiplied by minus 9.8 multiplied by 4 squared. Okay, now just put all of that into your calculator, and what you'll get is 78.4 meters. Okay, so it takes 78.4 meters. If you just look at this arrow, at this diagram here, right? So 78.4 meters it travels in the first 4 seconds to reach the top. The next part we're going to start off with is we're going to start off from up here on its way down over a second. Okay, so what we're going to do is we're going to do UVAST again, except this time we're going to basically start off from the top. Okay, so and we just segment this section here. Okay, so U is going to be equal to 0. We don't know what V is. The acceleration is now accelerating us favorably. It's actually bringing us downwards. Okay, so the acceleration is actually increasing the speed this time around. So the acceleration is going to be 9.8. We don't know what S is. We know that T equals 1. Okay, so we're looking forward to find out the distance. Let's use UT plus a half AT squared. Okay, so S equals UT plus a half AT squared. We're going to use that again. So we're going to get 0 times 1 plus a half 9.8 times 1 squared, and what that's going to give us is going to give us 4.9 meters. Okay, now to get the total distance traveled, we're just going to add both of our distances together. So the 78 and the 4.9 add down together, and what they're going to give us is 83.3 meters. Okay, and that is that question done. Now Next question. Two particles P and Q, each having a constant acceleration. If it has a constant acceleration, that's why it's in the linear motion chapter, okay? Are moving in the same direction along parallel lines. When P passes Q, the speeds are 23 meters per second and 5.5 meters respectively. 2 minutes later, or 120 seconds later, Q passes P, and then Q is then moving at 65.5. Okay, so very wordy question. Lots of different parts in this. Okay, so we're just going to start off with just. I always like to start off with a quick diagram just to get it into my head. Okay, so we can just say here. So what's going to happen is P and Q on two different rails. They both at one point they're moving the same direction. When P passes Q, so when P passes Q, the speed there. So P is going 23 at the start, and Q is going only 5.5. Okay, 120 seconds down the road. So P is in the lead of Q all the way up, and then all of a sudden they're level again. 120 seconds down the road. Okay, so 120 seconds later, this is what happens. Okay, they're even again, and at this point Q is then moving at 65.5. Okay, so Q is going 65.5, and P doesn't seem to be, we don't know what speed P is going at this point in time. Okay, so let's start off by UVAST in both systems. Okay, so UVAST for P and UVAST for Q. Okay, so we're going to UVAST P and Q, and let's see what they have. Okay, so we're going to make this, put this here in purple, UVAST. Okay, we're going to put P in red, and we're going to put Q in blue. Okay, so let's see what we have from both of them, right? So U for P, now this is for, let's say, the initial part of the journey. Okay, so for P, okay, U is 23. Its final velocity we don't know. We know that we're going to do it over the 120 seconds. Okay, so from the point where they first pass each other out to the point where they're both even again. So we're going to go the whole 120 seconds. Okay, so by using the full 120 seconds, it actually gives us more information. Okay, we don't know A and we don't know S for P. Okay, but what we do know about, so that's all we know for P. Now for Q, what we know for Q is that Q has a U value of 5.5 at the start. Its final velocity is going to be 65.5. We don't know the distance it's going to cover, but what we know is its time is also going to be 120 seconds. Okay, so if you look at both data sets, Q has more information. Okay, so we're going to go for Q, and for Q, and if we're going to do calculations in Q, it's going to be in blue writing. Okay, so for Q, phi equals U plus AT. Let's use them, because we could do it finding out what the acceleration is of Q. Okay, it's the first piece of information we could find, and then maybe after that we could find out what the distance covered in the 120 seconds is. So for Q, we're going to find out what phi equals U plus AT. So what's going to happen here is 65.5 equals 5.5 plus 120A. Okay, then we're going to get 120A equals 60. A is going to be equal to 0.5 ms to the minus 2. And as said before, we now know what the acceleration of Q is. So to find out the acceleration of Q is, we can put it in here. It's 0.5. Okay, so the acceleration of Q is now 0.5. Now, the acceleration of P and the acceleration of Q. We're just after getting the acceleration of Q, right? So that's the first part done. If we need more information about P, so the only shared variable is S, because remember, S is the same distance when P passes out Q, and then when P passes out Q, and then when Q is passing P, their distances have to be the same. So they have the same distances, okay? So if we calculate the distance of Q, we in fact calculate the distances for P, okay? So we're going to use Q's information, distance for Q, okay? And once we do the distance for Q, we're just going to use S equals UT plus a half AT squared. So S equals UT plus a half AT squared. And what we're going to get here is S equals UT. So that's going to be 5.5 T. So 5.5 multiplied by 120 seconds plus a half. A is a half as well. And T squared is 120 seconds squared. Going to put all that into your calculator. And what you'll get next is S equals 4,260 meters, okay? So 4,260 meters, 4260. Now we know that P also travels 4260. Now let's look at this. What we need to find out is what A is, okay? So we could use for P. So we want to find out the acceleration of P, the acceleration of Q, okay? So the target is the acceleration, okay? So this is the target, okay? We want to get A now, okay? So what we can do next is we can look at our variables and go, okay, we have S, T, and U. So let's use S equals UT plus a half AT squared, okay? Then let's just put in our numbers. So S equals S is going to be equal to 25, or what's it, 23? Sorry, 23 times T is 120 plus a half times A times 120 squared. Okay, and we know, as we know about S, is that S equals 4260. 260. Okay, now what we're going to get here is when we multiply everything out, we're going to multiply the two of these out and bring them over to your side, okay? And so what we'll end up getting here is we'll get 1,500. That's combining the two of these together, bringing this over to our side and taking it away. We're multiplying out this part here now. And what we'll get for that part there is we're going to be getting 7,200A. Therefore, A equals 1,500 divided by 7,200. And what we can get here is A equals 5 over 24. 24 ms to the minus 2. Okay. The next part now. We now know what A is. So we've got both accelerations, okay? We need to find the speed of P when Q overtakes us. So we need to find out our new target here is going to be V, okay? We now know that the acceleration here is 5 over 24. So just a quick rub out here. It's going to be 5 over 24. So now we have to find out our new target of V. I'll just say use V equals U plus AT. Quite easy. Once again, we're using red calculations to show that has something to do with P. Okay, so V equals U plus AT. Very easy question here. So V ends up to be 23 plus 5 over 24 times T, which is 120. Okay, and what we're going to get is V equals 48 meters per second. Okay, now the last question is the distance P is ahead of Q when they are moving with equal speeds. So this is basically a maximum distance question, okay? And a maximum distance question basically states like P overtakes Q at the start, okay? So because P overtakes Q at the start, basically P is going faster than Q, okay? So P overtakes Q at the start. They're going down the road, and P eventually opens up a distance over Q. So P is here. Let's say Q is lagging behind. Now, their velocities have to be equal. So V1 equals V2 at this point. this point means that P is no longer extending its distance on Q. And what we have to do is we have to find out what distance is the greatest gap, okay? So, okay, there's two things, okay? So we got to example our UVAST again. So once again, we're going to go for a similar system. P is going to be red and Q is going to be blue, okay? So P is going to be red and Q is going to be blue. And we're going to UVAST both systems again, okay? So let's see what we have this time around. Okay, division in the middle. Okay, what we know about P is it's starting off at 23 meters per second. We know its acceleration is 5/24. Okay, so what we know about Q is Q has a U of 5.5 and its acceleration is 0.5. Now, this isn't a lot of information to consider, right? It's not a good amount of information, okay? But what we do know is that V1 has to equal V2. Okay? So this is V1, so red V1 and V2. So we know they have to be equal to each other. We also know that the particles start at the same time. Two particles, when P passes Q, so they set at the same point at the start of the question, so they both have the same time, okay? So the time elapsed is the same, okay? So we're going to let T just equal T, and we're going to say T equals T. So T times are the same, okay? Okay, so let's start off with V1 and V2, okay? So V1 ends up to be U plus AT. Going to use U plus AT here. So we're going to get 23 plus 5/24t. Next we're going to get V2, and that equals 5.5 plus a half t. Okay, so V1 equals V2, and what this makes is 23 plus 5/24t equals 5.5 plus a half t. And then what we're going to get next is we're going to try and solve this for t, okay? And what we're going to get is 17.5 equals 7/24t. And the time taken, then t multiply across by 24, then divided by 7, and what you're going to get is 60 seconds, okay? So t equals 60 seconds. Okay, reread the question before you leave. The distance P is ahead of Q. So we're not actually looking for the time, we're looking for the distance, okay? So we found how long it takes. So all we got to do now is just put this into a distance formula, okay? So we know that T equals 60. You can choose either information set you want. You're going to use U, A, and T. So you're going to use S equals UT plus a half AT squared. And what you're going to get here is going to be S equals UT, which is going to be 23 times 60 plus a half AT squared. So 23 times 60 plus a half, 5/24 times 60 squared. Put it all into your calculator, and you're going to get the distance S equals, the biggest distance was 525 meters, okay? Okay, so the distance that in this timer, right, they started off equally. So you had to use both equations, okay? So this one here is the distance P covered, okay? So remember that they have a similar starting off point. Both of them start off at the same distance, okay? They both start at the same point. And then you have to get the distance. The greatest, the distance P is ahead of Q, okay? So when we put that in your calculator, it's actually not 525. It's actually the distance of P is going to be 1,755 meters, okay? And then S of Q is going to be the distance q covered, and we're expecting p to be ahead of q, so we're expecting a smaller number for s of q, okay? So it's going to be 5.5 multiplied by 60 plus a half times a half times 60 squared, and what this is going to get us is 1,230 meters, okay? So difference in distance covered. So this is the maximum lead as well. The difference in distance is 1755 minus 1230, and what you're going to get here is 525 meters. Okay. Next part, right? So this part here is 2007, question 1A. Okay, so we're going to try this out now. Okay. Find the value of u. So we want to know what the initial velocity is, okay, on these questions. And so a particle is projected vertically downwards from the top of a tower with speed u meters per second, right? So it's basically cannon down at u. Gravity is making it go faster, so acceleration is plus gravity, that's going directly downwards. It takes the particle 4 seconds to reach the bottom of the tower. Okay, so what we know about the bottom of the tower is that it's basically takes 4 seconds to get all the way to the bottom, okay? During the third second of its motion, it travels 29.9 meters, okay? So remember the language of the third second, okay? The first second is 0 to 1, the second second is 1 to 2, the third second is 2 to 3, and it's actually assisting you with the diagram, okay? It travels 29.9 meters, okay? Find the value of u. Now, please remember this is an interval question, okay? So let's make some points for us, okay? So let's call this point A, point B, point C, and point D. The rule of these questions is we always start from the start, okay? So we have 3 sets of information, okay? We have AB, we're going to have AC, and then we're going to have AD, okay? So 3 information sets, okay? So we're going to UVAST all 3 information sets, okay? And see what happens, okay? So UVAST all 3 systems, okay? And we're going to see what numbers we can get out. Okay, so we know that this is U because all of them are the same, so that's U. V we don't know. We know A is 9.8. We don't know the distance, but we know it takes 2 seconds to go from A to B. T0 to T2 is 2 seconds to go from A to B. Okay, the next one, which is AC, we know that U is still U. U is U. V, we don't actually know. We know A is 9.8. Okay. Let's call this distance on the first one S1. Okay. So we know that the distance for this one has to be S1. Okay, so we'll just rub this out for a sec. We don't know the distance at the start. Okay. And we know that T2 is going to be 3 seconds. To go to A to C, it's going to take 3 seconds, okay? So T equals 3. Finally, the blue one, U equals U. V equals we don't know what. A equals 9.8. S we don't know. And we know that T equals 4. Okay. So let's look at the information sets provided, and what we're going to try and do is we're trying to find the value of U and then the height of the tower, okay? So 29.9 meters, okay? So we know that this is the distance here during the third second of its motion is 29.9. So then we know that A to C is S1 plus 29.9, okay? Because it travels both of them. Okay, so S1 plus 29.9, okay? So let's try and do this now, okay? So for AB, what we're going to do is S1 equals UT, because we want U in the answer, so there's no point using V. We got to use U, okay? U is the target, plus a half AT squared. So we're going to get S equals UT, so U multiplied by 2 plus a half 9.8 times 2 squared. Then what we're going to get is S equals 2U. 2U plus 19.6, okay? So that's what S1 equals, okay? So this means that S2, which is in the red writing, S2 must be equal to 2U plus 19.6 plus 29.9 plus 29.9, and what that turns into is 29.9 so this part here, S2 equals 2U plus what's it, 49.5, okay? So we have a value for S2. Now we can also get a value for S2 by using UT plus a half AT squared as well, okay? And hopefully we can equate them together. So S equals UT plus a half AT squared for it. So it's going to be U times 3 UT plus a half AT squared plus a half 9.8 times T squared, which is times 3 squared. So S2 also equals 3U. S2 also equals 3U plus 44.1. Okay? Now, these two equations here, A and B, they're both equal to each other, okay? So what we now know is that 3U plus 44.1, I should be using red here still using the information. Okay, so 3U plus 44.1 equals 2U plus 49.5. We're going to solve for U. Then we're going to get U equals, bring over the 2U, comes minus 2U, bring over the 44.1. Okay, so we're going to get U equals 5.4 meters per second to the minus 1. Okay, so now that we've figured out what U is, what we have to figure out is what is the height of the tower? What is the distance A to D? Okay, so let's fill in the blue information. Okay, we know that U now equals U equals 5.4. We don't know what V equals. Okay, but we have enough information. We can now use S equals UT plus a half AT squared, because we know the time is 4. So S equals 5.4 times 4 plus a half 9.8 so half 9.8 times 4 squared. Put it all into your calculator, and what you'll get is it's 100 meters. Okay, so the height of the tower is going to be a good 100 meters. Okay, next part. Okay, a train accelerates uniformly from rest with a speed v to a speed v ms. Okay, v meters per second. Okay, it continues at this speed for a period of time and then decelerates uniformly to rest. In traveling a total distance d meters, the train accelerates through a distance pd meters and then decelerates through a distance qd meters, where p is less than 1 and q is less than 1. Okay. travels total distance d meters, and then accelerates through a distance pd meters, and decelerates through a distance qd, where p is less than 1 and q is less than 1. Draw a speed time graph for the motion of this train. Okay, so speed time, or Flossy time. Okay, so what we have here is our graph, and what we want to do is we have a maximum cap velocity of v. Okay, so the maximum velocity here is v. Okay, and what we need to do is uh, accelerate uniformly from rest. Okay, so what do we know? Is there any extra information we can get out of the question? Continues this speed for a period of time, then decelerates uniformly from rest. Okay, it doesn't actually tell us anything about the acceleration or deceleration. Okay, so that there isn't any information about that. Okay, so I'm just going to draw the velocity time diagrams if they're the same as each other. Okay, so what happens is it comes all the way up. This is the acceleration part. It hits a maximum velocity of v, then it travels at a normal range of motion, and then a normal constant velocity at this point, and then it decelerates back down to 0. Okay, so it starts from 0 to v, 0 to v, travels at v meters per second, then decides to decelerate. Okay, so what we can have now is we're just going to go down with this one here, okay, so we'll see what we have here now. Okay, so the following is going to be that's the velocity, and this is the time. Okay, and there's 3 different time intervals. The time intervals are t1, t2, and t3. t1, t2, and t3. Okay, so we're just after drawing the velocity time diagram for the question. That's now done. Now we're on the second part. If the average speed of the train for the whole journey is v divided by p plus q plus b, find the value of b. Okay, so what we need to do is we need to figure out how to get the average speed. Now remember, average speed is total distance. Average speed equals total distance divided by total time. Okay, so total distance divided by total time. Okay, so what we need to do is we need to get the total distance and divide it by the total time, and then put both of them equal to each other, and we can see what happens there. Okay, so let's go for the distance. Okay, so to get the total distance you need the area. Okay, so total distance equals the area of the triangle plus the rectangle plus the triangle. Okay, so this is what we need to get. So what we're going to get here is we're going to get a half. So remember, half base by height for the triangle. Okay, so t1v, vt2, and then t3v. Okay, so what we should get here is this. We should get a half vt1 plus vt2 plus a half vt3. Okay, now next thing we got to remember is it says the train accelerates through BD. PD is the area of the first triangle, and QD is the area of the last triangle. Okay, so we know that PD and QD is the areas of the respective triangles. Okay, now if we were to put this formula down, alright, what we'd have to do is we'd have to find the total distance divided by total time. We basically need, in our answer, okay, there's no t's. There's no t1, there's no t2, and there's no t3. Okay, so we gotta get rid of t1, t2, and t3. So in order to get rid of t1, t2, t3, what we know that this one here is equal to PD, and this one here is equal to QD. So what we need to do is we need to solve for t1. Okay, so a half VT1 equals PD, and I have VT3 equals QD. So what we can do next is we can get the T's on their own. So what we can try here is T1 equals 2PD over V. T2 ends up to be 2QD divided by V. Okay, so that's T1 and T3 respectively, okay? So the next thing we gotta do is we gotta find out the average speed of the train the whole journey, find the value of B, okay? So we found out what T1 and T3 is, okay? So we're gonna go back to our average speed formula. Okay, which is this here. Just gonna bring it down. Average speed formula. Okay, down the bottom. So what we can get here is we can get that this is the total distance, D divided by T1 plus T2 plus T3. Okay. So what we need to do is we need to get what, like T2 is the problem currently, right? So T2, we need to get T2 in terms of P and D, okay? So what we can do with T2 is that we know that the tire distance is D. So what we can say is that S1, first distance plus second distance plus third distance equals D, okay? And we know that the rectangle, which is S2, okay, this is S1, this is the third one, and that equals D, okay? But what we also know is that S1 equals PD. S2, we don't know. But we know that this one here is QD, and that equals D. Now we know that S2 must equal D minus PD minus QD. Okay? So S2 equals D minus PD minus QD. Okay? So what we can find out is that T2 or S2, which is V and T2, okay, which is equal to VT2. VT2 ends up to be equal to D minus PD minus QD, okay, and then we can get T2 is equal to D minus PD minus QD all over V. Okay, now we've gotten T1. Now we've gotten T1, T2, and T3 in terms of D, P, and V. Okay, so now all we gotta do is plug them in, and hopefully that we can rearrange it into V over P plus Q. Okay, so we'll see what happens now. So average velocity or average speed ends up to be D divided by T1 being 2. Okay, average speed, okay, so we know that T1 is 2PV over D. T3, and these are the three we're going to use, okay? So let's get started. So 2PD over V plus D minus PD minus QD all over V, and then plus 2QD all over V. Okay, so let's add all these together now and see what happens. Okay, so what we're going to get is going to have to add them all together. Okay, so we're going to get D divided by, now underline the like terms, this one, and minus PD gives you PD, just D plus D, and then this red one here cancels the 2QD, so what we're going to get is plus QD all over V. Okay, So we're going to bring this up and turn upside down. So what we're going to get is D over 1 multiplied by V over PD plus D plus QD. And then what we're going to get next is we're going to get VD divided by D. Now we got to factorize this part here, so we're going to get D into P plus 1 plus Q. Okay, the D's will cancel, and we're going to get left with V over P plus Q plus 1. And when you reread the question, B equals 1. Okay, and that's the end of 2007 part B.